Good afternoon to our 19th European EURADOS webinar. I should also maybe good morning and good evening here to our guests from other time zones. The topic of this webinar is quite an interesting one related to aviation topics, calculation of radiation exposure at aviation altitudes in case of solar particle events. You see already a nice picture here on the right side, which is given by the NASA Trace Satellite solar flares. The content of our presentation is summarized on these slides and gives additional to the time which we try to keep, of course, as best as to our possible talks and times, and maybe also your questions. We will open with a welcome from the coordinator of EURADOS Working Group 11 on high energy radiation fields. Then I will give you an introduction to EURADOS Working Group 11 Task Group 3, which is organizing this webinar, followed by characteristics of solar particle events affecting aviation by Erwin Flückinger from University of Bern in Switzerland, and followed by comparison of calculated radiation exposure for selected flight routes and events by Marcin Latucha from Cyberstorf Laboratories. Conclusion and perspective given by Jean-François Potelier from IRSN in France. And we will, to close our webinar by a Q&A session, where we invite you to participate with your questions. My name is Peter Becker. I'm from Cyberstorf Laboratories, and I would like to give the word now to Veronica from the Working Group 11 to give us welcome notes from the Secretary of EURADOS Working Group 11.
Thank you, Peter. Good afternoon, ladies and gentlemen. It's my pleasure to welcome you to this 19th EURADOS webinar, actually the third one organized by Working Group 11. For those who are maybe not that familiar with EURADOS, EURADOS is an association, a network of about 80 European institutions who are active in radiation dosimetry, gathering more than 600 scientists from all over the world. EURADOS promotes good practice in the field of ionizing radiation, and its work is organized in several working groups. In our case, this webinar is organized by the Working Group 11. I'm a secretary of this working group. The chairman is Marco Caresana from Politecnico di Milano. And this working group gathers researchers whose interest is high energy radiation fields. The work within the working group is then organized or divided into several tasks. So we have the task which is focused on comparison of different Monte Carlo codes. And then a task on dosimetry and pulse radiation fields. Task 3 is focused on improvement of the models for those assessment, which are caused by the solar particle events. And this webinar is organized by people active in this task group. Then we have people who are focused on measurements of solar particle events. Another who are working on development of high energy reference fields. Another task is focused on radiation dose induced by natural electric discharge in the atmosphere. Then another group takes care about the operational procedures for GLE management. And then two tasks which are focused on neutrons. The educational task on course on unfolding neutron spectra, and then benchmarking of the Monte Carlo models used for the neutrons of high energy. All the working groups of EURADOS meet at the annual meeting. This year is going to be organized in Porto in June. So everybody of you is welcome to join. We would be glad to meet you there. Last but not least, I should really mention that this work, which you will now see and which will be presented by you, is done by the Working Group 3, led by Peter Beck. By this, I would like to give him the floor, and I hope you will enjoy the lectures which we've prepared for you today.
Yeah, thank you very much, Veronica. Thank you very much for the welcome notes and the overview to the Working Group 11, which is a very exciting topic we are talking about, high radiation fields. You will see this also during this presentation. Before we go one step further, we have asked ourselves where you got this information of this webinar. And I would like to ask, yeah, Kerstin did it already. Thank you, Kerstin. She put an so-called a poll for everybody. Please answer it quickly before it is closed, and submit it, and we will see the results together before we go further in our content. Yeah, Kerstin gives us a little bit time, and in the meantime, when the polls are collected, I would like to give you more technical background information. You see on your right side chats, Q&A, and the poll area. The idea is that you use the chat under the public to ask technical question, or like Manelo from Sao Paulo in Brazil send us his hello. Hello also back from Europe. For the technical questions, please put your question then in the Q&A section. And as already said, the answers to the questions will be given at the very end, where we have also then spent more time for discussions and not after the presentation. But if you have questions to the presenter, please put them right now in this Q&A part and collect them, and not to forget this question. I'm sure they are very, very valuable and important contributions. Kerstin, can we see the results of the polls already now? Yeah. So, interesting enough, almost more than 50% looking continuously the EURADOS website and the newsletter. So the information comes from there. Personal invitation, as we expected, is a very good source to get informed about this. Social media is another one, as well as other information channel. So thank you very much for your feedback, and we will keep the EURADOS website and the newsletter attractive enough that you find all the interesting information here. Kerstin, can I get my slides back? Okay, and I will continue with in brief introduction to the EURADOS Working Group, Task Group 3, which is responsible for this webinar, and say a little bit more about this in this webinar. Acknowledgements to the contributions. I will start with this overview. There are a lot of names to mention, a lot of active people working on this topic. And what is the topic about of Task Group 3? Task Group 3 works on an objective to improve models for those assessments due to solar particle events and validate with experimental data. The first part of this objective, which is the assessment due to solar particle events, is already extensively done. With the validation with experiments, we are still working on it, and we probably need specific concepts, because it's not an easy task to measure solar particle events. I would like to emphasize here the report on this topic. It's the EURADOS report 2021-03. Here are the authors mentioned on comparison of codes assessing radiation exposure at aviation altitudes in case of solar particle events. Here's also a link which is possible for the public to upload it and to read them. And since I was responsible for this report, I'm very, very curious to hear from your side if you have already read this report, if you are aware of this report. Kerstin, could you give us the next polls to ask the audience about this? I see this is something which should come later. Could we have the question 4 before that, and then we change this? I hope this is still possible. If not, then we will continue with our questions where you are. Okay. Yes, this was the question which I mentioned. The question was, did you know about the EURADOS report 03 on solar particle events before this webinar? Yes or no, it would be here the answer, and we appreciate your reply. Okay, there is already the statistics. So more than 50% or almost 50% did not know about this report. Thanks God that we do this webinar, but at least 40% so knew this report already earlier. Which brings me to our next questions, and this makes it maybe a little bit more elaborative from which professional relation to aviation you are coming from. Kerstin, could you show us the poll number 2? So the question is here to give us the feedback from which section you are coming from. And it's then also very interesting for our discussion at the end, of course. Yeah, so unfortunately, it's not very specific. Other is a quite broad question, but nevertheless, we see a nice overview where the audience is from which section, from which area the audience is coming from, and we will take this into account and for the questions to improve our overview. We have prepared a third poll, and then we will continue with the content. Kerstin, could you show us our third poll, which is about what is your knowledge about radiation protection for aviation? If you are a professional expert, or if you have a good overview on it, or if you know just a little bit about this, or if you maybe do not know anything, or all these 4 questions are not applicable to you. So we see it's quite distributed. Thanks that the first questions are applicable for you, and we see that there is quite a good overview for the most of you, but also interesting people, they know quite a little, and I'm sure that this webinar will improve your knowledge about this, and I will continue to the next slide of my talk, which shows the motivation why we are doing this. Air crews and passengers are exposed to cosmic radiation. This is in the meantime in Europe and also in other parts of the world very well known and established. And this influence is coming by galactic and solar origin. Primary and galactic cosmic radiation, as well as energetic solar particles, interact with the atmosphere and produce cascades of interactions of secondary reaction products. In the next talk, you will hear much more about this, but so far, this is the brief overview of the effect. And decrease intensity with increasing depth in the Earth atmosphere is the consequence of the shielding effect of our atmosphere. And additionally, with the change in intensity with the variation of the Earth magnetic field, we have a second physical phenomena who acts as a shield for radiation which is coming from outside. Also here in the next talk, you will hear much more about this. Here two graphs which makes this more colorful, more in detailed. I show here the ambient dose equivalent over the standard parametric altitude. In total, the solid line shows a maximum around 20 kilometers. And here the different contributions of elemental particles, neutrons, protons, electrons, gamma muons, pions are the major contributors to this effect in the atmosphere or in altitude, in aviation altitudes. This is the influence of the atmospheric depth. And the influence of the Earth magnetic field is given here on the right side and shows with the parameter of, we call this cutoff rigidity, which means, which runs from 0 to 17. In the polar region, both North Pole and South Pole region, you see a 0, which means there's no effect of the magnetic field, which influence incoming particles, while in the equator region, there's quite a significant effect given by a cutoff rigidity of 17, which is the highest parameter here, which indicates that around the equator we have to expect the most effective shielding of our magnetic field for these particles. Also here for both effects, you will see in the second presentation more details. And then we distinguish, I told you already about so-called galactic cosmic radiation and solar cosmic radiation. This graph on the right side shows the proton flux over the energy. And what is quickly visible on this solid line and dashed line, that the energy distribution of these incoming protons is much less compared to contribution from solar cosmic radiation. And the energy distribution is also shows a quite a variety of solar cosmic radiation, which is then reflected in different effects if there are solar cosmic radiation influences affecting the aviation part, if there are higher or lower radiation exposure in aviation altitudes. While the galactic cosmic radiation is already well established and also introduced in standard procedures to assess the radiation exposure for the aviation air crews, the solar cosmic radiation is still under discussion, is still a scientific topic. This is one reason why we produce this report and why we give this webinar. On the right side, you see again the picture which I showed you already at the first slide, which is a post-eruptive loops in the wake of a solar flare. assessed by a trace satellite from NASA, which is quite an impressive picture of solar flares on the sun. I would like to summarize here the so-called 4 protective measures which are taken into account for cosmic radiation effects affecting the aviation sector. And in starting with to assess the radiation exposure of the crew concerned in each star 10 and effective dose. So ambient dose and effective dose. To consider the assessed exposure when organizing working schedule with a view to reduce the radiation dose of highly exposed crews is a very important measure on which has to take into account following the European basic safety standards. And another measure is to inform the workers, to train them and to inform them about the health risk of cosmic radiation and with their work involved. And last but not least, to apply the same special protection during pregnancy to female crew in respect to the child to be born as to other female workers. So these are 4 very important measures which are taken into account in the basic safety standards, and finally lead them to regulations in European countries in their national regulations how to deal with these effects and this radiation exposure to workers. Yeah, this brings me to the end and also already to the next promised talk, which is given by Erwin Flückinger from the University of Bern, Physikalisches Institute in Switzerland. And Erwin will also acknowledge his contributors, I'm sure, and he will talk about characteristics of solar particle events affecting aviation. Please, Erwin.
Thank you. Hello, everybody. It gives me great pleasure to present to you a few of the issues that are important for the understanding of the report we are talking about today. I acknowledge contributions by Ludwig Klein and Rolf Bütikofer for the preparation of this presentation. So for those who join only now, what are we talking about? If you are a passenger or a pilot, you are exposed to the radiation field at that altitude of the airplane, and the dosage you receive is due to the radiation field. And this radiation field, Peter has shown a graph what contributes to that at aircraft altitude. This radiation field is mostly due to galactic cosmic ray particles impinging at the top of the atmosphere. These galactic cosmic ray particles originate from far in our galaxy. They are permanent. They are sometimes modulated by solar activity. From time to time, on a sporadic scale, we also have a contribution from the sun, the so-called solar cosmic rays. And our reports concentrates now on the effect, on the contribution of these solar cosmic rays to radiation field and dosage at aircraft altitude. The phenomenon is illustrated in this figure here. These are not measurements, these are calculations. Imagine you are on a flight from Paris to Los Angeles on 20 January, you were on 20 January 2005. At the bottom scale you see the time in UT, and the flight, just by coincidence, was during the time when a solar particle event, which is marked in red here, GLE, was occurring. As what you can see is that During the flight, starting around 6:30 with the red line, there was a contribution, an additional contribution to the normal dose received by galactic cosmic radiation, marked in blue. You see that for about an hour, there is an increase of many factors, and it's only at the end of the flight that the contribution of solar particles is of the same order as what the dose was from galactic cosmic rays. So, for the understanding of the report and the following, some fundamental background information, and I apologize to the experts. I will start from very basic things. How do we observe and what are the manifestations of solar particle events affecting aviation? That's the first question. Let's go back to my first slide again. In principle, there are two ways. We have particle detectors in satellites or spacecraft in near-Earth space, marked on the upper left, and we have ground-based instruments positioned at the Earth. At the moment, there is no, as most of you know, there is no general measurement done in commercial airlines. So, what we do not take, let's go back once again, sorry. The measurements done by the particle detectors on satellites are mainly concentrated to lower energy particles, to a few hundred MeV. Of course, you can see that there are high energy particles present, but the spectral information about the high energy particles is not very detailed. On the other hand, by the ground-based detectors, you get information about the high energy particles, which are really doing increase on the radiation dose at aircraft altitude. So the ground-based detectors used for these measurements are called Newton monitors. No time to go into detail. They respond to the nuclei in the atmosphere, and their count rate is proportional to the cosmic radiation intensity at the top of the atmosphere. At the moment, the network of Newton monitors was established worldwide during the International Geophysical Year 1957, and the modern version of this global network is enclosed in NMDB, the worldwide Newton monitor network, a real-time database collecting high-time resolution Newton monitor data, and it also includes historical data archive. At the moment, there are approximately 30 stations worldwide providing online data, most of them with a time resolution of 1 minute and really in real time. The database is managed by Christian Steigis from Kiel, and we are very grateful to him that he is doing this job. Now, what do we see when we have, what do we see in Newton monitor data when we have a solid particle event, energetic solid particle event? You see on the horizontal line the time axis, and on the vertical time the relative count rate of a Newton monitor. The baseline is what the Newton monitor counts at that moment due to galactic cosmic rays. And so you see the logarithmic scale on the vertical. We have an increase here starting shortly before 7 o'clock QT. the maximum of about 5,000% with respect to the galactic cosmic ray background. And after this rapid onset, you see a decrease lasting for just sometimes can go up to hours. What we can see also that depending on the stations which observe and record this event, the response is different, and we will come back to that. The origin is always at the sun, and in the insert you can see for this event it was the active region 10720, and you see a spectroheliogram from the Meudon Observatory showing the source on the right-hand side. Now, the question is, why do we need a global network of ground-based stations for further investigating these solar particle events? The question is answered easily. First, the latitudinal spread. Here we use the geomagnetic field as a giant spectrometer to get information about the particle spectrum. And we also get information about eventual north-south anisotropies. On the other hand, the longitudinal spread of the stations allows for directional information on the longitudinal scale, because when the particles, charged particles, arrive to the Earth, they have to go through the magnetic field and they are deflected. And this allows somehow to go back and tell where these particles come from if we have a longitudinal spread of observations. Now, having said this, we already see that solar particle events affecting aviation are energetic solar cosmic ray events. And I emphasize energetic. You need particle energies of few hundred MeV up to the GeV region. Otherwise, there is nothing significant. And because we have these energetic particles, they have an effect at ground. We observe them with ground-based instruments, and then they are called ground-level enhancements with the abbreviation which I will use in the following, GLE. Now, second question, how often do GLEs occur? Part of the answer is given here. What you find in the upper panel of this figure is independence of time, starting in the left 1955 to today on the right-hand side. The sunspots number, solar cycles 19 up to solar cycles 25, where we are right now. In the lower panel, you see the vertical bars in blue and red, and these are the number of GLEs observed by Newton monitors during each year. And blue bars are all GLEs, and red bars are GLEs with an amplitude of more than 70% with regard to the galactic cosmic ray background. We can say that since 1942, remember cosmic rays were discovered in 1912, regular measurements started in the 1940s with ionization chambers. We have recorded 73 GLEs. Of these 73, 25 can classify to be strong events since 1970. That is strong, larger than 10% of the permanent galactic cosmic ray Newton monitor count rate background at sea level. This means we have an occurrence frequency of about 1 per 2 years, and the last one was in December 2006. Oops. Question is always super event. The very big ones. Of course, there are no measurements, direct measurements. Many of you know about the Carrington event in 1859, where we had a particle flux exceeding 30 MeV of more than 2 to the 10 to the 10th particles per square centimeter at the top of the atmosphere. Then from analysis of carbon or cosmic ray isotopes in 3 rings, there is the event at 775 AD. The reference is given, and we have a reference to the Carrington storm that missed the Earth. That's a more recent one, but fortunately, as the title says, it missed the Earth. Taking all the information about occurrence probability together, we have this figure on the right-hand side. On the bottom, there is the annual proton fluence for protons with energies exceeding 200 MeV. Why annual? This refers to the analysis method of 3 rings, where you sample annual ring samples. On the vertical scale, we have the occurrence probability, and I have marked on the higher left the 2 GLEs 42 and 69, which are referred to in the report we are discussing today. And the 775 AD event is on the right-hand side, and the very extreme event, where we don't have data in this plot, you can see the occurrence frequency 1 per 10,000 years. That's what we can expect. But as usual, this can happen tomorrow, so that's why we are working on our report. Now, characteristics of GLEs. If we want to characterize GLEs, that means we have to characterize the solar cosmic ray particles arriving in near-Earth space. And this characterization includes information about the energy or rigidity spectrum, about pitch angle distribution, anisotropy or isotropy, apparent source direction if we have an anisotropy, and we have to keep in mind that everything is dynamic with time. All these characteristics change with time, and every event is different from the other one. Let's start with the solar cosmic ray particle spectrum. Peter Beck has already shown this figure. What the reference is GCR, where you find as a function of energy on the horizontal scale, in the vertical, the proton flux in the given units. Of course, you know, galactic crossing rays are modulated, for example, by the 11-year solar sunspot activity, and there are short time modulations, for example, due to Forbush decreases. We also have in this plot few examples of particle spectra for solar cosmic ray events. You can see the general shape, and you can see that, for example, in the center zone for 1 GeV, the spectrum of the solar cosmic rays is factor of 100 or 1000 larger than the respective value of galactic cosmic rays. So everything is very dynamic. Next slide. Talking about isotropy and anisotropy. What do I mean with this? Let's have a look, as indicated on the left-hand side, to the Earth's magnetosphere and the space area surrounding the Earth's magnetosphere. Galactic cosmic rays, the permanent component I mentioned, these particles arrive almost isotropically from all directions in the vicinity of the Earth's magnetosphere. That's indicated with these arrows going around. Solar cosmic rays sometimes are isotropic, but mainly in the initial phase, they can be very anisotropic. And what does this mean? On their way from the sun to the Earth, the charged particles, solar particles, they spiral along the field lines of the interplanetary magnetic field. So we can expect that in the near-Earth environment, these particles arrive somehow in the direction of the IMF, the interplanetary magnetic field. And they have a pitch angle distribution around this direction of the interplanetary magnetic field, which is indicated here. And many of you know the direction of the interplanetary magnetic field in the vicinity of the Earth can change drastically. So we can expect solar particles arrive from any direction if they are collimated. But as I said, after some time, due to collision processes with inhomogeneities in the plasma of the solar wind, things are coming back to isotropy. Now, what is the effect of this possible anisotropy in the arrival of the solar particles and the geomagnetic effects of the bending of these particles when they go through the geomagnetic field and then enter into the atmosphere and produce the cascade and leading finally to the radiation field at aircraft altitude. We illustrate these effects here for the 20 January 2005 GLE. It's GLE 69. You will find this GLE later in the presentation. What we show here is in the upper panel the view to the north hemisphere, below a view to the southern hemisphere, and these are the areas reflecting the regions with enhanced radiation dosage when we assume that the solar cosmic rays were isotropic. And we can see that what we would expect, the regions are like an oval centered more or less around the northern pole and the magnetic pole in the south. Now let's assume we have a strong anisotropy, very strong collimated beam of particles, solar particles coming along the magnetic field line. And let's assume that the direction of the interplanetary magnetic field was in the so that the source was in 0 degree south, so in the equator. The longitude is given here in 264 east. And you see the general surrounding shape is similar to the left, but now we have a structure. There are periods, regions where we have almost very small effect, and we have regions where we have a very strong effect. This is due to the arrival of a collimated beam of solar particles, and again, the regions affected at the Earth are also collimated. Now for the real GLE 69, the calculations of the analysis during the main phase, because the arrival direction was not in the equatorial plane, but it was very, very south, almost 85 degrees south. So we can see that there is a strong anisotropy of effects when we compare northern and southern hemisphere. We have a strong effect in the southern hemisphere and very strange regions which are affected on the northern scale. So for the entire event, you have to imagine that the start is with a situation as shown on the right-hand side, and going back to later times in the event, we return to more isotropic situation as shown on the left-hand side. But of course, the intensity would then be much lower. Now, to quantify the radiation field at aircraft altitude for the assessment, theoretical assessment of dosages, we have to keep in mind that the solar particle events are defined by the characteristics of solar particle events near Earth, spectrum, information about anisotropy and possible arrival direction, and in addition, the level of galactic cosmic rays and geomagnetic activity. So this leads us to the principle of those calculations during GLEs. There are two elements. The first element, you have to define or find your baseline, and the baseline is the dosage which is due to the galactic cosmic rays at the time you are looking at. Peter pointed out there are certified standard procedures. This element is well known and can be handled. The element 2, you have to calculate the dose due to the additional component coming from solar cosmic ray particles, and this means you have to take into account the characteristics of the GLE particles, you have to take into account galactic cosmic ray modulation and the level of geomagnetic activity. For this, you have different codes or different approaches. One, as illustrated here, one class of codes deals with Monte Carlo simulations. That means you start in principle with Newton monitor data as indicated on the lower left. You use the Newton monitor data and satellite data in a process, in an iterative parameter fitting, to determine the characteristics of the solar particles near Earth. This is usually an iterative process, parameter fitting process. You take into account 20 to 30 stations, and depending on the models, you have about 10 free parameters. If you have the characteristics of solar particle radiation at the top of the atmosphere, you then can use your Monte Carlo codes, cascade, simulate a cascade in the atmosphere, get the ionization, and have a dose conversation at the end. And this will give you a result about the dose you have at aircraft altitude. Another class of codes indicated here on the lower right, they couple directly to Newton monitor data and try to scale what Newton monitor recordings show to doses to be expected at altitude. Now, shortly, the two GLEs selected for the study. We had two events. Both events are based on real cases, but we have to deal with PIs who have to use input for their models. And therefore, we had event one, a synthetic event, where we predetermined from our working group all the input parameters needed for those assessment calculations. That is date and time. We assumed that the particle flux near Earth was isotropic at all times. We defined the form of the spectrum of the solid particles. We said this form is constant throughout time. The only thing that changes is the amplitude of this spectrum at 1 GeV based on Newton monitor data. This is illustrated here. On the left-hand side, you can see as a function of time the characteristics of this GLE as observed by the Newton monitor station McMurdo. The fine red line are the Newton monitor data, and the black line are the data which we supplied as a intensity time profile to the users of the study. And the according spectra of the primary particles are illustrated for three cases on the right-hand side. You can see a spectrum at the onset phase indicated by the black arrow, the violet, the pink arrow in the maximum phase, and finally in the recovery phase, the green spectrum. This was the information which was available to the PIs doing their studies. The second GLE is GLE 969 on 20 January 2005. We already met this GLE. You find here on the horizontal axis time from 5:30 to 1600 on 20 January 2005, and the vertical axis, the increase in percent of the Newton monitor count rate. Please pay attention, this is a logarithmic scale, and you see the recordings of 4 selected stations in the northern and southern hemisphere. This event is very special. It was ranked among the largest GLEs since the beginning of Newton monitor records. And you can see that during the main phase, the first 1 hour, we have a strong north-south anisotropy, which can be observed. That was also illustrated in the plots I showed. And you can see that the maximum increase in the maximum phase is of the order of 4,500% in the south polar regions. So this was the information which was available to the PIs on all necessary input parameters which was needed for their codes. They had to determine them themselves by publicly available GLE information, and this comes much closer to reality than in example 1, where we had given all the input. And I think with this, I conclude my part and I hand over to Peter and Martin.
Thank you, Erwin. Peter would like to.
Yeah, thank you very much, Erwin, for this very detailed and interesting talk about quite a complex physical situation, cosmic radiation affecting the aviation sector. I would like to point out, if you have further detailed questions, and I'm sure you have, either put them in the Q&A section for our discussion after the webinar, or after the talks. And also I would like to encourage then, of course, for further reading to have a look to the report where all these topics are described in detail in a report which up to 100 pages. Yeah, our next talk is about comparison of calculated radiation exposure for selected flight routes and events, which reflects exactly these two GLEs where Erwin was talking about. And here there are then comparison of calculated radiation exposure, which Martin will explore in more detail. Please, Martin.
Thank you, Peter. First, thank you, Erwin, for bringing us closer the GLE characteristics that we used in our studies. I will present you comparison of the data that we have gathered during these two studies. And yes, I will start with the content of my presentation. First, I will say something in the introduction, how we composed our study, what we asked the participants for. Then I will give a quick overview about the calculation codes or models, and also on the selected flights. And then I will go into a presentation of the data that we obtained and show you some comparison. This will be, of course, only an excerpt from the report. The time does not allow to discuss this very much in detail. And if anybody is interested in the details, and I encourage you to download the report and read it. So as a form of introduction, we have obtained data from 9 codes or models, and we presented all of them in an anonymous way. The reason for is that some of the codes are used for regular radiation protection services, some are internal, some are external, some are used only for scientific purposes, and we didn't want to disturb these arrangements. Then we selected 3 flights, 3 representative flights for which we expected to have good results. And this was a 1 transatlantic flight, 1 polar route flight, and 1 southern hemisphere flight. We knew these flights from before, from our exercise that we took in 2012. There has been a report, EURADOS report in 2012, comparing codes for GCR only. And there we had like 23 or even 24 flights. We have taken just 3 of them. We asked participants to give us results separately for galactic cosmic radiation and for solar cosmic radiation, so for our selected ground-level enhancements. And these should be supplied in 2 terms. In terms of operational quantity, ambient dose equivalent, H*10, I will refer to this one as H*10. And for the radiation protection quantity, effective dose. Here I would like to mention that all the calculations of effective dose were done according to ICRP 60 recommendations. Those data should be given to us in terms of root dose, so just 1 number for H*10, 1 number for effective dose for the whole flight, but also in the form of dose rate, so for every waypoint of the flight. So this will be clear when I switch to the next slides. But before, an overview on the codes. I said we had nine codes. This is the table which we have in the report. My intention here is not to go too much in detail. With this table, I'd like to emphasize two things. One, that we have these two elements that Erwin Flukiger mentioned. Every code is capable of giving a galactic cosmic ray assessment and solar cosmic ray assessment. So in these two columns, we have information about galactic cosmic ray, how this is treated in the code, and in these two columns, we have information how the solar cosmic ray is given. And if you read carefully in this table, you will see that the codes are very different. As Erwin said, we have mainly two families. One which is a pool of code which is based on Monte Carlo simulations, but we have also other codes. We have codes that rely on empirical or semi-empirical models. Also, there are some models that take into account some even analytical solutions. For every code in the report, you have a detailed description. So if anybody of you is interested in one particular or all of them, then please go to the report and you will have all the details there. Now about the selected flights. We have selected 3 flights. One, which you can see on the, all of 3 you can see in the left figure. The first one, 202 from Chicago to Beijing. This is the northern flight. One flight from San Francisco to Paris, which is the transatlantic flight, and one flight on the southern hemisphere from Sydney to Johannesburg. You see that the flights are represented here as a dots and a line. The line is actually only to guide the eye. What we have given to the participants is information at a certain time of the flight, exactly when the yellow dots are. And a different representation of the flight is presented on the right-hand side. Here you see the altitude profile of the flight. These are the yellow, the blue dots. So you see the flight has changed changed altitudes. And the second parameter is vertical cutoff rigidity. For us, basically, this is a measure of geographical position. When the vertical cutoff rigidity is low, like here between, let's say, 5 and 9, the flight is close to polar region. So it would be here in this case. And when this parameter is somewhere higher, then of course the flight is closer to equator. You can have these figures, the flight profiles for all of them in the report, also with the exact numbers. So it's not only graph, it's also the number. Yes, the next task, what we did, we prepared those flights in such a way that that we should expect some results. So for GLE 42, we defined exactly the date and the time for the starting of the flight in such a way that all of them happened when the GLE was ongoing. So you have seen this figure already. This is a synthetic or artificial event that we created based on the real GLE 42 event. The red curve here is the relative counting rates of neutron monitor station in McMurdo. And the black one is the solar cosmic ray amplitude as it has been supplied to the participant. On the right-hand side, you can see how the flights were adjusted to the GLE 69, which happened on January 20, 2005. And for this, we have not specified anything else. It was only a list of literature, and all the participants could use this literature or use their own information and just supply us the results. In the figure, you can see the count rates of neutron monitor stations. There are 3 of them. The red one is Terre Adélie, the green one is Oulu, and the blue one is Thule. And as it has been already said, this event is very interesting because it has a quite strong anisotropy phase in the first hour, and then it has a very long 5 hours long isotropic phase. It is interesting because not all the codes are taking anisotropy information in the same manner. So this is also a parameter that will be seen in the results then. And now I jump to the results, what we have got. The first figure on the left-hand side are the results for galactic cosmic rays in terms of H-star 10 for the GLE 42. And we see that the value are around 50 microsievert for every flight. On the right-hand side, I present the same quantity, ambient dose equivalent, the same flight, but the results are the sum, the galactic cosmic ray and solar cosmic ray, also in terms of H-star 10. We immediately see two things. One thing is that the value is much larger. The calculated root dose is much larger, and it is larger from a factor of about 2 to maybe even 4 or 5, depending on the code. A second interesting observation is that perhaps there is a tendency of some grouping here, which is visible in this flight, a little bit less on these two flights. If we do the same figure, so root doses for effective dose, we have a similar figure, similar pictures. A little bit difference is that these 3 points seem to be slightly higher than previously, but overall it is pretty much a very similar situation. The effective dose in the sum for galactic cosmic rays and solar cosmic ray is larger, again by factor of about 2 to 4 or 5. If we look on the same figures, but for the second exercise, for the GLE 65, then we do see different things. First of all, the left graph, which was for galactic cosmic rays, has a different scale here. I did this on purpose to see that we do also have some spread here. And also to see that the median values, which are marked in red, are slightly higher than previously. If you remember, if I go back quickly to this one, it was 50. And then we have always above 50, the median. This is something what we expected. The date is different. And then the solar activity is different. So the galactic cosmic ray intensity is also different. So the codes were sensitive enough, of course, to see this effect. On the right-hand side, I have the ambient dose equivalent for the sum for galactic cosmic rays and for solar cosmic rays. And the first thing what is very visible is that the values are larger. They are above 100, reaching even some 600 microsievert per flight. The distribution is more evenly. So previously I said maybe there is some kind of grouping. We don't see this grouping here anymore. The values are also higher by factor from factor 2 to factor 5. The same figure for effective dose. So comparing to H-star 10 for galactic cosmic rays, it is similar. However, we see that the effective dose tends to be slightly higher than H-star 10. And the right figure shows the sum for galactic cosmic rays and solar cosmic ray. here we see that the spread is lower than previously for H*10, but we have to remember that not all the codes deliver the same amount of results. So we have cases that we received results only for exercise 1, or only for H*10, or only for effective dose. So in this case, for this figure, the amount of data that we have got was the lowest. I also said that we analyzed the data in terms of dose rate, and this is just one example how we have done this. These figures you will have in the report for every GLE and for every flight. I present just 2 of them here. So what we see, all the dots are the waypoints, and at every waypoint, participants gave us effective dose rate values, and as expected, when the GLE starts, also the values go higher, and they tend to follow the same profile as the GLE had. This was for the synthetic event, for the GLE 42. Very interesting is what happened with the GLE 69. You see that because the event was very strong and very abrupt, we also see this in the data. And particularly interesting is that some codes gave dose rate values higher than 1 millisievert per hour. This is something very interesting, which of course lasts only 5 minutes for one waypoint, and this quickly goes down. But nevertheless, it's an interesting information. Then, with all of this data, we try to group them in a kind of aggregate form, and to look closer on the deviation. What is the spread in the data that we have got? On the left, in the left figure, you see GLE 42, and the circles are galactic cosmic rays. The triangles are solar cosmic rays, and the diamonds is the sun. So if we analyze the 3 flights for galactic cosmic rays only, we see that they are more or less plus minus 20% for all of them. It is different for the triangles. We see that the spread is from, let's say, plus 30% in this case up to minus 80%. So there is a quite large spread. And again, this grouping. For GLE 69, the situation is a little bit different. The GCR are again from some plus 20 to minus 30, which is more or less as expected. But the spread for solar cosmic rays is much, much larger. So in this case, in the extreme case, we have the spread from minus 70% from the median up to plus 75 perhaps percent. With this, we would like to close the report with one number that is, or 2 numbers that are easy to remember. So we tried to do a kind of statistical analysis for GCR separately and for solar cosmic rays separately. And we did this for GCR to compare the results that we had in 2012. What we found out that in both cases, for GLE 42 and GLE 69, where of course only GCR plays some role, the relative deviation from the median was around 11%, very consistent. And this was a very positive message, very good message. It was not so good for when we looked at solar cosmic rays. For GLE 42, the relative deviation from the median was 29%. And when we went to the real case, when everything was open, everybody wanted to use what they want, the spread was 50%. And with these figures, I conclude my presentation. Yes.
Thank you very much, Martin. Thank you. I got several questions, and I would like to encourage you even put more of your questions in the Q&A session. I got also a question with regard if there a link of the webinar will be established later on. Maybe Kerstin will say much more about this, but as far as I know, there will be a link in a YouTube video, but Kerstin will talk about. The next presentation is done by Jean-François, who talks about the conclusion and perspective of the study. Please, Jean-François.
Okay, thank you, Peter, for the transition. I am from the Institute of Radiological Protection and Nuclear Safety, France. As shown in the previous presentation, it's a quite a complex context and situation, and the dose assessment is not always, it's obvious, is not always an easy task. So I will start by a short summary. Don't worry, it will be not too long. So first, the GLE characteristics may vary in a wide range. That means in terms of intensity, energy spectrum, anisotropy, at the Earth surface, as shown in the previous presentation by Erwin in particular. So that means that we have to take into account, to consider many input parameters to be used by models. And in addition, for some of them, with very large uncertainties. The second point is that GLEs are not predictable events. So that means that the dose assessment is to be done a posteriori. There is no forecast for such events. We have selected GLEs for this study. We have selected 2 GLEs, the 2 most important of the last 40 years, because we have some input data. So it's why we, as explained by Erwin and Marcin, we have chosen these events. Some other points, we have selected 9 codes used for calculating those due to GLEs on board aircraft, and some of them are currently used on a routine basis for occupational exposure. As shown, there are 2 main families, one using Monte Carlo techniques and calculations, and the second one using semi-empirical solution based on fit to experimental data. And we have selected the most exposed route at high latitude. So in conclusion, the increase of the dose may be significant for a given flight at high latitude. For example, it's for the GLE 42, it's 2 to 3 times the effective dose due to GCR for the root dose, and for GLE 69, it's 4 to 6 times the effective dose due to galactic cosmic rays. So, in conclusion, it's significant for a given flight, but it can be considered as neglectable in comparison to the annual dose for crew members. So it is important because we have very often questions from crew members when there is an event. So it's important, can be multiplied by 2, 3, but well, again, the dose in comparison to the annual dose is very low. And the second point is that the better the input are known, the better the results are. it can be shown in the result presented by Marcin. We have differences of about 30% for GLE42. And in this case, we have we use the same input parameters, in particular regarding the proton spectra. And when we have not so precise or input parameters, the uncertainty is larger. For example, 30% for GLE69. So that means in a real situation, the reliability may be significantly worse. So it's to be it's important to know this, because when and if we have to communicate, it's an important aspect. Now we come to some recommendations. So the first one is to investigate for a traceable and robust procedure for the determination of the primary proton spectral data for GLEs. So it's a task which is identified for several years, but we have not yet effectively started to do something on this point. The second one is to validate the models by experimental data. So one of the solutions is to do, as you know, it's very rare events with a very low frequency. So that means we have to perform continuous onboard measurements. And there are already existing initiatives with some airlines. We will see this later. And the last recommendation is to define a procedure to decide to consider or not to consider a ground-level enhancement for dosimetric purposes. And it's an ongoing action within the Working Group 11, using in particular neutron monitor data. For example, we could imagine that we select the few neutron monitor with the criteria, for example, if the neutron flux increased by at least 10%, we could, on 1, 2, or 3 neutron monitors, it could be a criteria to consider a GLE for dosimetric purposes. As an example of measurements, on the right part, it's data coming from Peter Beck, and it's measurement during a GLE with a TPEC. And on the left part, it's a continuous onboard measurements on board Boeing 37 using a most simple dosimeter. It's a ULIN. It's energy deposited spectrometer. And here it's an example to show, currently, for example, at Air France, we are dosimeters flying on board more than 30 aircraft. That means, and we have, as far as I remember, there are about 20 aircraft flying, being at altitude at the same time. So that means we are covering quite well all the Earth surface. Here it's an example of two. We have superposed the data coming from 2 aircraft. So you can see that the time is quite well covered. And we hope this system is in place for about 10 years now. And we have not yet seen a GLE because there was no GLE. So we hope to see it, to see a GLE very, very soon. So, and it is my last slide. So, Peter, you...
Yes,
Thank you very much for your attention.
Thank you very much, Jean-François. Thank you for your summary. Yes, definitely, validation is an import by measurements is an important issue. And before we go in the Q&A section, let's go in the Q&A, and I will start with some poll questions to you. And we see already some Q&A questions collected by the auditorium. So the next slide is Q&A. Thank you, Kerstin, for the question. And the first one, which probably is very curious for us who wrote this report, did this webinar encourage you to read or reread the EURADOS report 2021-03 on solar particle events for additional information? Yeah, please give us a reply on that. Thank you. And the next question, which we thought about would be interesting. Do you think that, and this goes directly to the summary of Jean-François, do you think that additional reference measurements in aircraft are needed to validate radiation exposure calculations? Also here, I appreciate a reply from you all. Yeah, validation by measurements, as we said already, of course, is the only thing how we can validate our models. Nevertheless, it's quite a difficult task to do this during events which are very hard and very difficult to predict. Since Erwin told us, since the 40s we collected 773 of these events, and this means in taking all events into account, maybe this is one event per year, and even one event per year is difficult to measure. So it needs a very good strategy to do this. Jean-François showed you that it was possible during the Halloween storms to catch something which was by a fixed installed instrument. Do we have already? And there is another poll by Kerstin. How important is radiation protection in aviation for you? Also, this is a very, very important question for us to take into account your position. Is it very important and necessary for you, for your profession or where you are working? Is it important and need to know about for you? It's not really important, but good to know about. Or is it not important at all for you? Or the fifth is I don't want to answer this question. So please give us your reply on that. Yeah, while we are waiting all your answers, we have collected some questions in the Q&A, and you also see them. I expect more from you. Yeah, there's a last poll before we go into the answering the questions. How important are future developments and improvements of calculation codes models for you? Is it very important and necessary? Depends where you're working. Are you working with models, etc., or you are responsible for this? Is it important and progress would be welcomed for you, or it is not really important and the current status is good enough? The current status was reflected in this report. So this is the current status. What you see the uncertainties when experts use their models and compare them, or is it not important at all, or you don't want to answer? Please reply to this question. Yeah, as I said before, please write us your questions in the Q&A section to the whole webinar, or a question which you just came into your mind when you're listening to this webinar, or a specific question to one of the experts. Now is your chance to do this. Kerstin provided in the public chat also information about the webinar, which will be provided by a PDF at the EURADOS website. This will be available to download to download the presentation, and there will be also an access to the recording of this webinar. Also, this will be, as I see here, on www.youtube.com/EURADOS will be available soon. Before we look to the results of our polls, I would like to go to the Q&A and answer the questions which we have so far in this box. Kerstin, is there a way to show the question to all of us? Yeah, thank you very much. This is the first question by Maniello Pelem. I hope I spelled this name correct. I guess it's from Sao Paulo, I guess. If emission solar cosmic radiation is isotropy and Earth has very little spheral radiation angle, so probably to emit in Earth direction is very low. This question goes directly to Erwin, I guess, and to his presentation. Erwin, could you give us an answer on this?
Well, yes. If I understand the question correctly, it aims at the connection of this Earth to the source of solar cosmic radiation at the sun. Excuse me. And it's clear, if we don't have a good connection via the interplanetary magnetic field between the source at the sun and the Earth, the effect at the Earth is smaller or larger. And it is true that depending on the solar longitude, where the emission of solar particles occurs, the effect at the sun at the Earth is high, or cannot, or is missed at all. As I said in the example of the huge flare that missed the Earth, which was at the solar longitude where the magnetic field connection to the Earth was not present. However, I used the terms isotropy and anisotropy more in the context of particles in the neighborhood of Earth, so around the Earth's magnetosphere. So there may be a little disagreement between the understanding of the two meanings of the term, but if I understand correctly, the question, it aims at the fact that not every huge event occurring at the sun will hit the Earth, and that's true.
Thank you very much, Erwin. I hope this answer the question of Manuel. There is a further question by Casper van Dam. Airlines are sometimes bound by law to use a specific code which does not include solar cosmic radiation, but only calculates those rates due to galactic cosmic radiation. This means that even if the airlines want to, they cannot use solar cosmic radiation codes. Does EURADOS have experience with these laws in Europe and the process to amend, update them? It's a very good question. Partly true and handled different in different European countries. This question appears during the presentation of Jean-François. Before I say something more about this, I would like to hand over this to Jean-François because it's a direct question to EURADOS. Please, Jean-François.
Yeah. Well, in Europe, we have both situations. I mean that some countries are using only model for GCR, and other ones, sometimes depending on their national law, are using also models for GLEs. But well, there is not a general rule in Europe, at least. For other countries, I am not completely aware on what are the practices. But perhaps, Peter, you have some.
Yeah, I can add this, and in particular the situation in Austria, for instance, it's clearly written in the radiation protection law that these effects from, I guess the text is like this, that from sporadic events from the sun, unexpected events have to be taken into account. So it's a clear message that laboratories, institutes who deal with radiation protection issues to air crew and cosmic radiation have to show that their codes are able to do this in Austria. And I agree with Jean-François, this is not the case in all European countries. Yeah, and I guess the question was more, does EURADOS have experience with these laws in Europe and the process to amend, update them?
Well, yes, EURADOS in general is not involved in the in writing and setting up laws. So we at the national level, we can be involved we can help to write laws, but EURADOS officially is not involved in the laws.
What we can say for EURADOS, Jean-François and Caspar, is for EURADOS is working within Working Group 11, in particular here Task Group 3, on the improvements surely on the scientific, but finally also on a routine base to improve this and to establish this knowledge and spread out this knowledge, in particular with a focus to harmonize this knowledge, that all the European countries finally are able to do so, to provide such a service. Yes, so this is the assistant by EURADOS. Jean-François showed it on one slide where even a step further in another task group of Working Group 11, in Task Group 10, we work on a practical procedure. What are the steps? What are necessary steps to undertake when such a GLE appears? And this report will provide for sure more such an practical support also for other European countries, and to make it on an easy level. What we show here is really this is a very top level how to deal with such events on the best knowledge we have in every GLE case. It's maybe not necessary to do this, and this will be discussed and will be also then worked out in task group 10. Anything further, Jean-François or Erwin?
No, just to mention that at EURADOS we are working to establish recommendations which can be maybe used by in the different countries to set up laws, and well, it's only recommendations and harmonizations. Yeah.
Definitely, yeah. Since I have no further question, if I'm correct, no, I have just a thank you from Caspar. Thank you very much for your question, Caspar. Kerstin, could you give us the answers of the last polls we did? This is the polls 5 to 8. Could you show us the answers? No, this we did already. I was asking for the answers.
Yeah, I'm sorry, I had to reopen them again to show you the answers. Just a second.
Technical issue. So everybody can answer again?
You can answer again, but I don't know what happens when you try to answer again.
Yeah, in the meantime, I have a further question by Uwe. Okay, so obviously we have to continue with the polls thing. In the meantime, I have another question by Uwe. Uwe O. What are the changes of generating new experimental measurement values? Okay. Who feels keen enough to answer? Marcin, maybe you. I guess the question goes in this direction. What new knowledge do we expect from new experimental measurement? Or experimental measurement values. I guess this question goes in another direction. What do you mean with measurement values, new measurement quantities which are discussed now? Is this your question, or what do you mean with new experimental measurement values?
I think just the new measured GLEs, the new experimental data. Yeah, exactly. That is, yeah.
In order to validate the codes, yes.
Yeah.
The point, Uwe, is that we do have just a few measurements. There are measurements. You saw them. There are also publications when you Google and show on the I guess journal Radiation Protection Dosimetry, for instance. There's a nice publication overview of measurements during solar particle events. There are measurements. Unfortunately, the measurements which are available are not, let's say, controlled enough that we do not know everything what is necessary to know when you do a validation. So the measurements are not precise enough. This is the current situation of most of the measurements. So therefore, validation are needed to go in the order of plus minus 30% or even better in in what you saw now in the literature is not the case there. The Halloween measurement, what Jean-François showed you, has been done by TPC. The validation is quite good. Others are maybe with a larger error bar. This is one thing. And the other thing is that institutions which work in radiation protection dosimetry, they have been asked by their control agencies, accreditation agencies, for instance, that they have to show regularly, every 2, 3, or 5 years, at least an intercomparison and a validation of what they are doing, and to show that this is still meaningful. If we enter in the business of solar particle events, those assessment, this is very, very tricky because they are very, very rare. But nevertheless, it is necessary to do. And here we need, as I already said, concepts, strategies, how to do this, and to be evident that what we are calculating is meaningful with regard to measurements. Would you like to add something?
No. The question is, what are the chances of generating? So the chance is depending on the next GLE.
Yeah, I mean, the chance increase if you put an instrument and measure continuously for month for month over several years, and then you will be able to measure it. This was the strategy for the Halloween measurement. We put an instrument on the aircraft and then waited maybe 1 or 2 years, and then we measured it.
Yeah, because one point, the challenge is not to perform a measurement on the second flight or route. What would be very interesting is to have at the same time measurements on different routes to assess the anisotropy, for example.
For instance, yes, also.
It's a very important point, which is
still
to be validated.
Yeah, it's quite an expensive task. Yeah.
So we must be simply lucky. We must put a lot of instruments, and the task itself is not so easy. As Peter said, the calibration of the instrument is very important. And you must have all of them. And ideally, as Jean-François said, we should have the same instrument everywhere to capture anisotropy. To capture anisotropy, and also for the value itself.
Well, just a remark regarding the calibration. There is an ISO standard defining a procedure for onboard calibration using a reference instrument like a TPC, tissue equivalent proportional counter, which provide the kind of reference, those on board. And we do regularly calibration flights using TPEC as a reference instrument, and with many other dosimeters which are used in the second time in different aircraft, trying to cover, well, the largest surface part of the Earth to get data in case of GLE.
Yeah. I have another question in the Q&A box. Is effector avionics also covered by EURADOS? Which working group? Thank you, Van Lee, for your question. Yeah, I mean, quick answer is so far not. It is actually not really the focus of EURADOS so far. So this is a clear answer. Jean-François, do you have more prospective outlook for Van Lee?
No. I have the same answer. answered. To avionics, no, but there are other organisms assessing effects on avionics in different countries. The Space Agency, for example, are performing assessment, such assessments, for example.
Yeah, this is you're completely right. The space agencies are more involved in.
For Airbus is doing such assessments, so for example,
yeah, Airbus in these organizations. So EURADOS is definitely not focused on this topic. Yeah, we spent already quite a lot of time, much more than we promised to talk about this topic. Thank you very much for your questions. A final Q&A poll we have still prepared for our participants. How would you rate the overall quality and usefulness of the webinar for you? So please also here give us your reply. And maybe we can see this, Kerstin, then the answer. So far, 0%. Okay, it's increasing. So at least 5-star and 4 stars in the order of some 80%, 85%, which I very, very much appreciate. Thank you very much for your positive voting of this webinar. As Kerstin said, we provide you the presentation by PDF to download from the EURADOS website. We provide the records by YouTube video. Go on to youtube.com/EURADOS. Kerstin, can you give us a brief timing? When do you expect that it will appear? Maybe she will give something in the chat. Okay.
I'm sorry, I try to do it as soon as possible, but I need my colleagues from SEK who have to send it before.
Oh, okay, so it will take a certain time. It's not tomorrow. This is, I guess, what the people are asking.
I think it should be online next week.
Yeah, this is a reasonable answer. I saw already also in the polls the replies for the other questions. So briefly, let us go through how much important for the future development is. Also here, I see important and progress would be welcomed is the majority, as well as very important. So we see. Thank you for the feedback that we are working on an important topic. How important is radiation protection and aviation for you? Also here, we see the community which is listening to us is interested in that, and that the reference measurements are very important, is rated here by a very, very high rating, almost 80%. And the webinar encouraged you to read our report. This was also one of our aims, as well as I already said, the webinar was some useful for you. And yeah, this brings us to the end of our webinar. I hope it was useful for all of us, for all of you. Yeah, I would like to thank all the experts, all the background organizers to organize this webinar. Thank you very much, and wish you still a nice afternoon, and see you until the next EURADOS webinar. Bye-bye.